bonds, then the formation of covalent bonds. Let's first of all look at formation of ionic bonds. This type of bonding takes place between oppositely charged ions. Like you have, for example, as discussed earlier, sodium ion, you have chloride ion. So there is a force of attraction between the oppositely charged ion. The force of attraction is its electrostatic force of attraction. This usually occurs for compounds made from a metal and a non-metal. The sodium ion comes from the metal sodium, and chloride ion comes from the non-metal chlorine. Now this type of bonding force occurs by electron transfer, where metal atoms donate electrons to non-metal atoms. Sodium is a metal atom, chlorine is a non-metal atom. Sodium loses an electron to gain a positive charge overall, and chlorine gains an electron to form a negative charge overall, becomes chloride. Sodium becomes sodium ion, and chlorine becomes chloride ion. As discussed earlier, these ions are held together in an electrostatic lattice. There is an electrostatic force of attraction between the oppositely charged ions plus and minus. Let's look at the formation of these bonds, these ionic bonds, with a dot and cross diagram. Let's look at first of all sodium. It is in the first group of the periodic table. So therefore the valence shell has only one electron, and the atomic number is 9, so the proton number and number of electrons are also 9. So there will be 2 electrons in the first shell, 8 in the second shell, and 1 in the last shell. On the other hand, if you look at chlorine, it is in the 7th group of the periodic table. So there are 7 electrons in the valence shell, that is the last shell. So it needs to gain 1 electron to have a stable electronic structure. So there are 2 electrons in the first shell. There are 8 electrons in the second shell, and there are 7 electrons in the last shell. So basically what would happen is that sodium would lose its valence electron to chlorine, and it would lose the last shell, and so therefore overall there would be 8 electrons in its last shell, and chlorine would gain that electron to have complete 8 electrons in its last shell, so it would also have a stable electronic configuration. So as sodium has lost an electron, overall it has one more proton than the total number of electrons, so overall it has a positive charge. Sodium has 11 protons and 10 electrons. So as it has 10 electrons, it overall has an extra proton overall, so therefore an overall positive charge. Chlorine on the other hand, one more electron is greater than the overall number of protons. Overall there is a negative charge on chlorine and it becomes a chloride ion. The number of protons in chlorine are 7. After gaining electron, the electrons become 18. The number of electrons is 1 greater than the number of protons, so therefore overall a negative charge. Now we will look at the formation of covalent bonds. Remember that covalent bond form between atoms of nonmetals. For example, there is an atom of nonmetal X and an atom of nonmetal Y. There can be a covalent bond between the atoms of these two nonmetals, and this will happen by sharing of electrons. In ionic bonding, there was a transfer of electrons, but in covalent bonding, there is a sharing of electrons. There is no transfer of electrons. Let's look at another example of water molecule. There are 2 atoms of hydrogen and 1 atom of oxygen. There is a covalent bond between hydrogen atom and oxygen atom. There is a sharing of a pair of electrons, one from hydrogen, one from oxygen. Oxygen is in the 6th group, so it has 6 electrons in the outermost shell. It needs 2 more. Hydrogen has 1 electron in its outer shell, so it just needs 1 more. This type of covalent bonding can happen either in small molecules as well as in larger molecules. Let's look at the sharing of electrons in a dot and cross diagram in a water molecule. Hydrogen has 1 electron in its outer shell. Oxygen has 6 electrons in its outer shell. Let me draw this diagram again. Here is an hydrogen atom. It has 1 electron in its outermost shell. Oxygen, on the other hand, has 6 electrons because it is in the 6th group of the periodic table. Now 1 electron it would share with 1 hydrogen atom. Now it has 7, and 1 electron it will share it with another hydrogen atom. Now overall there are 8 electrons in the outermost shell of oxygen, 2, 4, 6, 8, and hydrogen has 2 in its outermost shell, and this hydrogen atom also has 2. So overall there is stability. Look at the covalent bonding between 2 hydrogen atoms in a hydrogen molecule. Hydrogen has only 1 electron in its outermost shell, so it just needs 1 more. It shares that electron with another hydrogen atom and overall forms a stable structure. And this is the dot and cross diagram showing the covalent bond present in a hydrogen molecule.